So, in the last video, we learned what integration actually means, and today we're going to start integrating expressions ourselves. So, we'll learn the first rule that most of the heavy lifting in early calculus does. And so, just a quick reminder, if we was asked about differentiating x cubed, then we know y prime equals 3x squared. And if differentiation multiplies by powers and lowers exponents, how do you think we reverse that? Let's build the integration rule, the power rule. So, if we want to reverse this, how could we get back? Well, what have we done? We times through down to here, and we've taken one away. So what we could do is we could add one back on and divide through by whatever that original power was. So if we had y prime equals, let's say, x n, well, y is going to be x to the n plus 1 all over n plus 1. We're just reversing what the differentiation rule is for powers. So let's do another example. Let's do the integral of 2x. Well, we would want to reverse what has ever happened here. And so applying the power rule, let's add 1 to the power. Well, what is it currently? It's to the power of 1. So 2x to the 1 plus 1, that's just 2x squared. And so now we can divide through by whatever power we just got, which is going to be 2, which gives us x squared. Does this work? Well, let's say y equals x squared, and we want to differentiate. Pull the power down. Y equals 2x. Take one away. Do we get the same function? Yes, we do. So this rule is true. And so basically, you're just adding 1 to the power and dividing by the new power every time. There's one value that breaks the rule, and it's that n equals minus 1, because the denominator becomes 0. So if we have the integral of x to the minus 1, we add 1 to the power, we're going to get x to the 0, and dividing through, that doesn't work, does it? We're going to deal with that in a later video. We'll call it some kind of mystery right now, and we'll learn how to tackle that at a later date. So now, let's just do some more questions. Let's do this. The integral of 5x squared. This is the first integral I've given you where there's a constant. And so visually, what you can actually do is you can take this out of the integral. So you can call this 5 logs of the integral of x squared. And we've done this a couple of times now. We know that the answer to this question is just 2x. And we have a 5 here. So we're going to be left with 10x plus c. What am I doing? Yeah. What am I doing? Seriously, no. This is bad. The answer to this is a third x cubed with our power rule. And so we have a 5 on the outside. We're going to have 5 over 3x cubed plus c. Apologies about how terrible this 3 looks, but that's the real answer. So constants can sit outside the integrals is what I was trying to get at. And let's do another example. Let's do the integral of 10x to the 4. Well, this is 10 log to the integral of x to the 4. The integral of x to the 4 is 1/5 of x to the power of 5 using our power rules, times in through by 10 is going to give us 10x to the 5. You can just include it linearly. So if we had like I've just done 10x to the 4, you can just divide 10 by 4 from the get-go, divide it by 4, and then add 1 to the, add 1, sorry. Well, we can do this as 10x to the 4 plus 1 divided by 5, which will just give us this 2x to the 5. But, if you wanted to just keep it to having x's, then you can always pull the constants out. What should we do when we have multiple terms? let's look at the integral of a polynomial. Let's do 3x squared plus 2x plus 1 dx. Now, this is the same, technically, as the integral of 3x squared plus the integral of 2x plus the integral of 1 dx. For all of these, by the way, there should be a dx here, there should be a dx here. I didn't write it out. It doesn't matter too much. But let's integrate them. The integral of 3x squared, add 1 to the power, 3x cubed. 3 divided by 3 is just 1, so we're going to have x cubed. Add 1 to the power, divide by the new power here. 2x to the 2 divided by 2 is going to give us x squared. So plus x squared. And then this one here, when we have a 1, it's 1x to the 0, because x to the 0 is 1. So this is the same as 1 plot of x to the 0. And if we add 1 to the power here, well, we're going to get 1x to the 1 divided by 1, which is just going to give us x. And that's where, when you have just a number, you're going to get that divided by that number. So if you have a 5, you're going to get 5x. If you have an x, you're going to get x. Sorry, if you have 1, you're going to get x. So this is going to be plus x plus our constant of integration c, because like I said, one of these terms could have had, it's not, but it could have had like 3x squared minus 5 was the original, sorry, it could have been x cubed plus 5, because that would still just give us 3x squared, right? Like, if the original function could have been like this, x cubed plus 100 plus x squared minus 5 plus x. When we differentiate, we're actually just going to get 3x squared plus the 2x plus 1. And we've lost this term and we've lost this term. But, so that's what this plus c is. And in this case, if we know our numbers, it'll be 95. So all we do when we have a polynomial is we integrate term by term. Let's do some worked examples now. Let's do a couple of questions. Let's do the integral of x to the 5. Try and do it yourself. The answer is going to be 1/6 x to the power 6 plus c. Let's try a slightly longer one. Let's do the integral of 4x cubed minus 2x plus 6. Add 1 to the power, divide by the new power, you're going to get x to the power of 4. Add 1 to the power, divide by the new power, you're going to get minus 2x squared, minus x squared. This one is going to become plus 6x plus c. Nice and simple. Let's do the integral of 7. Oh, let's do the integral of 7x to the minus 2 plus x to the 4. Now, adding 1 to this power is going to give minus 1. So, and then dividing through by the new power is just going to give minus 7x. Adding 1 to the power here, dividing through by the new power, plus 1/5 x to the 5 plus c. Nice and simply. Now, let's introduce some fractional powers, nice and simply. Let's do the integral of x to the half, which is the same, by the way, this is semantically equivalent as the integral of the square root of x. So if you see this in either form, this is how you do it. Same again, add 1 to the power, you're going to get x to the 3/2, and 1 divided by 3/2 is just going to give 2/3, and so our answer becomes 2/3 x to the 3/2 plus c. Let's do one more here. Let's do the integral of x to the minus 3. Add 1 to the power, divide through by the new power, you're going to get minus 1/2 x to the minus 4. Sorry, what am I doing? It's a quarter. Wait, no, it's not. Let's do it. Let's actually write out the power rule here. X to the minus 3 plus 1 is going to be x to the minus 2. Divide through by the new power. 1 divided by minus 2 is just going to be minus a half. X to the minus 2 plus c. Nice and simple. See, even I can make mistakes with just the power rule, so it's always important to practice here. Some common mistakes are divided by the old power, so a lot of people will do like the integral of x cubed is going to be x to the 4 over 3, but it's not. It's going to be x to the 4 over 4, but that's a common mistake some people make. Or they'll try and apply the power rule to x to the minus 1, which we discussed earlier we can't do. So I'm going to leave you with an integral to do, and I'll leave the answer in the comments. Can anyone tell me what the integral of 5x to the 4 plus 3x squared minus 2 is? Try it out yourself. I'll leave the answer in the comments. In the next episode, we're going to move on beyond basic powers, and we're going to look at probably let's look at some trig functions next. And yeah, this has been the Power Rule.